High-dose benzene exposure from air pollution has been shown to increase oxidative DNA damage in a dose-dependent manner in people, while even low-dose exposure to benzene from air exposure and gasoline exposure has been shown to epigenetically change genes that are involved in suppressing leukemia.
Yes, chemicals from nail polish do get into the body. It's not staying in a medium that's not being absorbed. It's actually going through the nails into the capillaries. Again, we don't know how much and how long over time, but we do know it has the capability. A 7-fold increase in 10 to 14 hours after painting your nails is significant, and on my opinion, with acrylic. I actually believe acrylic nails are the worst of all nail treatments, even more so than gels. And I just talked about gels and the UV light and my concern with it, because it can cause nail damage, allergic reactions, things like eczema, etc. And it's from the methacrylate. And this is what's causing the nail damage. But it also contains chemicals like benzene and formaldehyde, which we know are carcinogenic and have enough evidence to show that it does cause cancer.
But when it comes to showing off the ability of sulforaphane to help trigger systems that boost the excretion of carcinogens, there's really one study that stands out. This study demonstrated that sulforaphane and its precursor, glucoraphanin, can actually significantly increase the excretion of benzene. Participants that were given a daily broccoli sprout beverage containing around 262.5 milligrams of glucoraphanin and about 7.1 milligrams of sulforaphane, which is about probably an effective dose of something like 135 grams of fresh broccoli sprouts per day, increased the rate of excretion of benzene by 61%, beginning on the first day of consuming the drink and continuing throughout the entire 12-week period of the trial. Just so you know, benzene is a carcinogen that's been shown to cause cancer in humans and in animals, particularly leukemia. The major source of benzene is from automobile exhaust and air pollution, but also from cigarette smoke, even secondhand. The major source of benzene for non-smokers is from air pollution, whereas smokers are mostly exposed to benzene from cigarette smoke. In fact, in the US, cigarette smokers are exposed to around 10 times more benzene than non-smokers. There are plenty of other sources that we can be exposed to benzene from. Air pollution is another place we get it. That's because air pollution in the United States primarily comes from automobile exhaust, which is a source of benzene. High-dose benzene exposure from air pollution has been shown to increase oxidative DNA damage in a dose-dependent manner in people, while even low-dose exposure to benzene from air exposure and gasoline exposure has been shown to epigenetically change genes that are involved in suppressing leukemia. If we wish to concern ourselves with air pollution, however, we should look to a study published in 2008 on the use of a broccoli sprout homogenate. This study found that broccoli sprouts, when administered as a homogenate, had a direct effect on increasing the expression of phase 2 detoxification enzymes in the upper airway. In other words, right where it counts. The doses they gave to individuals ranged from 25 grams of broccoli sprout homogenate all the way up to 200 grams, with a clear dose-response relationship, where the largest dose had the most potent effect, strongly increasing the production of various glutathione-related enzymes such as glutathione S-transferases, heme oxygenase 1, and NQO1, which is an enzyme we talked about earlier when we discussed breast cancer.
Moringan is similar and likely more active than the sulforaphane found in broccoli. Let me say that again because it's huge. Moringan is more active than the sulforaphane found in broccoli. Just like the isothiocyanate in broccoli, the entire reaction is dependent on one enzyme called myrosinase. Both myrosinase and glucomoringan are stored in the moringa plant, but they're stored in separate compartments. The enzymatic reaction occurs when these little compartments or cell walls are broken down, allowing the two compounds to mix and react with each other.